Assalamualaikum warahmatullahi wabarakatuh. Okay, let's continue flexibility method. This time we are going to analyze composite structure. Okay, let's look at into the learning outcome. At the end of this lesson, you should be able to understand what is composite structure and the difference between beam, frame, and truss. Next, you should choose the right redundant member, because in flexibility method, we will solve the redundant first, then only we can solve remaining reaction. So we should be able to choose the right redundant. And redundant for composite structure is always the EA member. Okay, after that, we have to analyze reaction and internal forces in the primary and redundant structure, because we know that we will solve the redundant by solving compatibility equation. Compatibility equation is come from principle of superposition. It is actually displacement. So to get displacement, we should have internal forces, and internal forces we get from reaction. So we have to analyze reaction and internal forces first. Okay, and after that we will substitute into the formula of displacement, and we will get displacement in primary structure and in redundant structure. So both displacement we will substitute into the compatibility equation. We solve the compatibility equation for the redundant value, and after that we will solve the remaining reaction at the support. Okay, what is composite structure? Actually, composite structure is combination of EI and EA in one structure. EI is flexural rigidity. We normally consider EI when we analyze beam and frame, and we consider EA when we analyze truss. And in composite structure, there are combination of EI and EA under one structure. Basically, it is combination of beam and frame with element of truss. An element of truss can be a strut or a cable which carries axial effect. In structural analysis, composite structure are analyzed to determine their strength and stiffness. Okay, since beam and frame has bending effect. Bending effect is actually refers to EI, the flexural rigidity. The composite structure is an indeterminate structure. By using flexibility method, an indeterminate beam or frame and in an indeterminate structure, we have to have the primary structure and redundant structure. And the primary structure is actually beam or frame. And the EA member is the redundant. The EA member is the redundant. Okay, let's look at example 1. Okay, in the figure 1.4.1, we can see that it is composite structure. It has combination of EI and EA. Member AB is beam and EA is strut. Okay, so this beam AB link to strut BC at B, and we have to calculate the force in the strut. The force in the strut can be solved using flexibility method, and we have to choose force in member BC as the redundant. Okay, the EI and EA is given as shown. Okay, so what we need to do is we have to understand that this is composite structure, and in composite structure, the primary structure is beam and the redundant is the EA member. Okay, so the redundant is force in member BC, so we name as FBC. And from that, and from principle of superposition, we are producing the compatibility equation. Remember that the compatibility equation is actually displacement. So we will have displacement in primary structure and displacement in redundant structure. Okay, delta 1 node is displacement in primary structure, and F11 is displacement in redundant structure. And since in composite structure we have to combine EI and EA, means we have to combine the formula as well. So we will integrate two moment equation like what we have done in beam and frame analysis, and we have to plus this with the displacement formula that we use in thrust analysis. Okay, and then we have displacement in redundant structure F11 as stated, combination of EI and EA as well. Okay, so let's look at the primary structure. The primary structure is a structure after removing redundant. When we remove member BC, the beam is a cantilever beam, and a cantilever beam is determinate beam. So this cantilever beam is subjected to 10 kilonewton per meter UDL, and we need to calculate reaction, and after that we have to write moment equation. Okay, next is redundant structure. In redundant structure, it is also cantilever beam, and this time it is subjected to a unit value of FBC. Remember BC is the redundant. Okay, a unit value of member BC. So we have to apply parallel with the member. So we apply a unit value at B. Okay, and it is just like inclined force. So the inclined force we have to resolve in x and y, and we use the trigonometry to resolve. The angle is given. So from the first triangular, we can have the x length and the y length is 5.362 meter and 4.5 meter, and using that we can interpolate to get the x value, which is equal to 0.766, and y value is 0.643. From that, we will determine the reaction at support A, and AY is negative 0.643, and moment is 6.43 clockwise to remain equilibrium. Okay, so this is what we should do when we analyze redundant structure. Okay, so under this redundant structure, member AB is EI member, and don't forget we are the a unit value of FBC that we put, that is for EA member. So we have to consider EA for EA element, a unit value as the force, and we write moment equation for beam for EI element. Okay, so we will have two table 1 for EI table and table 2 for EA table. So in EI table, it is just like the table that we use to analyze a beam and frame. We integrate moment equation. We produce moment equation. We integrate two moment equation to produce displacement. So we list all the EI member in the table, and member AB has EI, so we put AB here. We choose origin. We have to put limit, and from the primary and redundant structure, we have M0 and M1, and we write the moment equation as usual. And for table number 2, it is called as EA table. So EA is has only one member. We get from BC. A struct is EA element. So it is BC only. The length is 7 meter. The length is 7 meter. N naught is equal to 0, because in primary structure, there is no N naught value, and N1 refers to a unit value of FBC. That is why we put 1 here. Okay, so there is no value for N1 and L, and we get one value for N1 square L, and it is equivalent to 7. Okay, we substitute the moment equation and the N value into the displacement formula. So for delta 1 node displacement in primary structure, we get only from beam. from beam, so the value is 0.241 meter. And for displacement in redundant structure F11, we get a combination of EI and EA. So we get 0.145. Okay, 7 over 100,000 is actually come from EA element, table number 2. Okay, so these two displacement, we have to substitute into the compatibility equation. Delta 1 naught plus F11 times FBC is equal to 0. And when we solve this, we get the redundant FBC. So we get the force in strut FBC equals to negative 166.207 kilonewton. After redundant has been determined, we use the redundant to solve the remaining reaction. There are 3 remaining reactions at support A. We can solve using equilibrium equation, or we can also use the principle of superposition. We just need to remember the general equation. Actual structure equals to primary structure plus redundant structure. Okay, so AY in actual structure we get from AY in primary structure plus AY in redundant structure. Remember, in redundant structure, we have to times with FBC. So that is how we analyze, how we determine the remaining reaction using principle of superposition. So AY is 100 plus negative 0.643 times FBC. It is equal to 206.87 kilonewton. AX, since it is beam, the value is 0. There is no horizontal force and horizontal displacement. And moment at A in actual structure equals to negative 500 plus 6.43. Negative 500 is moment in primary structure, and 6.43 is moment in redundant structure. And remember, in redundant structure, we have to times with FBC, the redundant. So the moment at A in actual structure is equal to negative 1568.711. Okay, so that is how we analyze composite structure. It is actually combination of EI and EA element. It may be combination of beam plus EA member, or frame plus EA member. And always remember, the EA member is always the redundant in the structure, in the composite structure. So we have to remove the EA member first. And after that, we will continue analyze as usual. We calculate reaction and internal forces to get the displacement, and displacement is actually the input in the compatibility equation. Solving the compatibility equation, we get the redundant, and once redundant has been determined, we can continue to solve the remaining unknown reaction using either equilibrium equation or principle of superposition. Okay, I hope you get something from this session. Okay, that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.